Let me check to see if it's recording. It is. All right, good. Okay, so we're going to finish up R2 finally, part D. It took us 4 days to do it, all right, but we should be able to finish today. So the title of this lesson is called Evaluating Square Roots. Okay, I'm just going to write square roots down. Square roots. Now, we did talk about exponents last time we had a lesson, didn't we? Talked about exponents to a certain power and all that kind of thing. Well, square roots are kind of like the inverse of that, okay? It's like the opposite of squaring something, all right? So that's what we're going to do, square roots. And let's see, it looks like, yeah, they just do square roots. There are other types of roots. There's cube roots, fourth roots, fifth roots, and so on. But we're just going to concentrate today just on square roots. So that would be kind of like the opposite of x squared. So if I do x squared, you take a number, you multiply it by itself. But if I did a square root, now you could, if you wanted to, put a little 2 out there, but really people don't usually do that, all right, because they already know that if there's no number outside of there, it means there's a little 2 outside of this. By the way, we give this little symbol right there, we give it a special name. Does anybody know what that name is besides square root, the actual symbol itself? Very good. You did learn it. So it's called a radical. Back in the 80s, back when I was in high school, that was like the thing to say. If something was really cool, people would say, oh, radical, man. You ever watch movies, old movies, right? And they say radical. Yeah, we actually used to say that for about 5 minutes, and then it went away, and then nobody ever said it again. But that's not that kind of radical. But this is a square root, specifically a square root if there's no number out in front of there. Now, we're not going to do this today. Will, you done? So we're not going to do this today, but there are other roots. You could have a cube root, or you could have a fourth root, or a fifth root, or sixth root, or whatever. So you'd put those numbers out in front. But a square root is so common that they just don't bother putting a little 2 out in front. You could if you wanted to, but there's no reason to. Okay, it's just assumed we know that if there's no number out in front, then it's a square root. We good? Okay, enough of that. Sometimes, yeah, okay, that's good enough. Here's a little definition. This is straight from the book. It says, if b squared is equal to a, then b is equal to the square root of a. All right, so that's pretty important. We're going to be doing that kind of stuff a lot. All right, so if b squared is equal to a, then if you want to get b by itself, which you did right here, how do you get rid of a square? You do the opposite. So what's the opposite of squaring something? Taking the square root of it. Well, let's talk about what in the world a square root means. So if I had like 3 squared, what's 3 squared equal to? It's 9. All right, so let's go the other way. Let's take the square root of both sides. So if I took the square root of this side, and then I did the same thing to both sides, which you're allowed to do in algebra, right? Whatever you do on one side, you can do that as long as you do it to the other side. It's got to be balanced, okay? What happens here? Like, we could use this thing from here to here. If b squared equals a, what did they do? They just got rid of the square, didn't they? They turned it into a b. So what happens here? We just get rid of the square. It just turns into a what? A 3, okay? Equals. And then what is the square root of 9? You've done square roots before. This isn't the first time you've ever seen this. So what's the square root of 9? It's 3, exactly, okay? I don't think they're going to be real picky about it, but to tell you the truth, maybe later on they will. We'll talk about that in a second. I'm getting ahead of myself. But look what this square root and this square does to each other. What do they do to each other? They just kind of vanish, don't they? Or they do what? It's a word that we've taught before. They kind of starts with a C. They cancel each other out, don't they? Okay? That square and that square root, since they're opposites of each other, they cancel each other out. So that's how you can get rid of a square, by taking the square root of it. Now, as long as you do it to both sides. You got to do it to both sides, or you just can't. You can't just out of the blue take the square root of something and expect it to just be a 3. All right, you got to do it to both sides. Everybody with me? Now, technically, I'll say this, the square root of 9, what this is actually saying, like when you square something, you're taking a number, you're multiplying it by itself. This says, what number multiplied by itself is equal to 9? You follow me on that? That's the question you have to ask yourself with a square root. What number, if I multiply it by itself, am I going to get the number that's inside of this? So what number would that be? But not just a 3. Let's think more algebra. Now, square root of 3 is a different number. Square root of 3 is like 1 point something. All right? So that's not the same. What other number multiplied by itself is equal to 9? 3 times 3 is 9. What else times itself is 9? 1 times 1 is 9. 9 times 1, but that's not itself. 9 and 1 are not the same thing. What number times the same thing? The two same numbers multiply together to be 9. Yeah, we said that already. I'll give you a hint. Positive 3, we said. Tell me why. Because negative 3 times negative 3 is what? Positive 9. So again, the question is, what number times itself is equal to positive 9? Well, negative 3 times negative 3 also is equal to positive 9, isn't it? Okay, so a lot of times we'll do this. If they have, and when you get into a little bit higher algebra, not really high, we'll be doing that stuff, okay? Pretty soon, probably. I can't remember when. But they'll do this. They'll put a plus or minus, because what does that mean? You actually get two answers. You get positive 3, and you also get negative 3. You with me? That's why they do this. Instead of writing 3 and negative 3, that would be a pain, wouldn't it? So it looks a lot more concise like that. But it doesn't look like in this section right there, they're going to care about the negative, okay? In this section right now, we'll just stay with the positive version of it, okay? So if I asked you the square root of 25, what would you tell me? 5. Easy, okay? The square root of 121. 121? 11. 11 times 11. You know your multiplication tables? Did you ever have to learn those when you were a kid? I heard they don't teach that anymore in a lot of schools, multiplication tables. They should. It's always good to know them. All right, enough of that. Let's talk a little bit more about square roots. There's like four things I'm going to talk about right here. You cannot have, so there's no negatives. I'll just put NEG inside a square root. Inside, I'll just put the symbol, okay? There's no negatives inside a square root. Let's talk about that for a second. So if I had the square root, let's use 9 again, but let's stick a negative in here. Remember what the question we have to ask ourselves? What number times itself, what are the same two numbers, the exact same two numbers, multiply together to be negative 9? Are they the same exact two numbers? Is negative 3 and positive 3 the same two numbers? Nah, technically not at all. Not at all they're not the same number. Because positive 3 lies here, negative 3 lies over here. Zero's in the middle. You with me? Are they even close to the same numbers? No, they're not even next to each other, okay? So can it be negative 3? Can it be positive 3? Can it be a fraction? Can it be a decimal? Is there anything times itself, two of the same exact numbers, that multiply to be negative 9? No, because the whole idea of, in order to get a negative, one of them has to be what? Positive, and the other has to be negative. Is there any way that the same two numbers are going to work here? No. So you cannot have a negative. Now, we will talk about this later. This is a number, but it's not a real number. Okay? Did you learn this in Algebra 2? It's a what? If you got real numbers, and then you have imaginary. Very good. Have you heard that before? You just came up with that. Yeah, exactly right. So you did learn it. You just didn't remember it. Okay? That's right. You remember you used the lowercase I for imaginary numbers. We will get to that eventually. I'm not sure when. I can't remember off the top of my head. But we will get to imaginary numbers. So, but they're not real numbers. It's not on a number line. It's not on a real number line. Everybody got that? Okay. So that's the one, I don't know what you would call this, but there's just 4 things that we're going to learn about this. Now, you can take the square root of 0. Why? Because, again, ask ourselves the question, what number times itself is 0? 0 times 0 is 0. So can you take the square root of 0? Absolutely. All right? So it's 0. That's pretty easy. I'm not going to take the time to write this down. You can write it down. I just wrote down that the square root of a positive number is always, it says here, the square root of a positive number is always positive. But you can get a negative answer, though. So I'm not sure about number 3. I'm going to put a question mark right there. Okay, I'm not sure why they said that. So we'll skip number 3. Let's do one more, and we kind of talked about it already. This is just my 4th point. I think this is in the book. So what if you take the square root and you take a square? I don't care what that number is right there. What's that going to equal? If I square a square root, we talked about this just a few minutes ago. What happens with the square and the square root? What do they do to each other? They cancel each other out. So what are we left with? C. So if I asked you what the square root of 723 is, but then I put a square right there, is that really a hard problem to do? It's very simple now, okay? Because I don't have to figure out what the square root of 723 is and then square it. I know that the square and the square root are just going to cancel each other out, and I'm just left with 723. You with me? Okay. Let's do a couple examples, and we will be finished. Let's change colors. I'm tired of that. All right, so let's do example 11. So if you ever wanted to look in the book, that's where it is, example 11. And we got some parts to it. So let's just do this one. This is very easy. The square root of 64. If I asked you what the square root of 64 is without using a calculator, what number times itself is 64? 8. Very good. You're getting it? Oh, now we're getting a little trickier. Square root of 1 over 16. Now, let me show you a little trick. I don't think they did this. They should have, but I'll show it to you. There's a rule for multiplication and there's a rule for division. I tell you what, let me use the multiplication rule. This isn't in my notes. I'm not sure why it's not there, but okay, what if I did this? What if I said the square root and then 3 times 2 in there? There's a rule that says that we can do this. Everybody watching? What's happening with that 3 and 2 inside of there? Okay, they're multiplying, okay? So what I can do, there's a rule that says we can do this. We can separate them into their own little individual square roots and then multiply those together. You see that? It goes both ways. So if I gave you what is the square root of 3 times the square root of 2, you would tell me what? It goes both ways. So what could you do? If they both have square roots, you could put them under one big square root and then do what to them? No, just multiply them. Just multiply them, okay? Now, what is the square root of 3 times 2? It's just the square root of what? 6. Now, from there, I'm not going to simplify that. It's already simplified. I can just keep it square root of 6. Believe me, we got a whole section on doing a lot more with square roots than we're doing right now, okay? This is just touching it. It's just scratching the surface, okay? Now, what do you think might be true about division then? Exactly right. Take their own square roots, put one on the top, one on the bottom, and do like that. Okay, just like you did with multiplication, you can do the same thing with division. Does that make sense? Now, we could figure this out. What is the square root of 1? It's 1, right, because 1 times 1 is 1. Over square root of 16 is, and then that's your answer. You could have done, well, yeah, that's the way you want to do it. Okay, that's the way you want to do it. So if you have a division or a fraction inside a square root, just break them up. Put the stuff on the top under a square root, take the stuff on the bottom, put it under a square root, and then if you can figure it out, then figure it out, okay? I will show you one thing since we've done it here. What if I asked you this? What if I asked you, I'm not going to get all into this because we will eventually. What would I do here? Well, what did I say earlier? Let's take the square root of the top and then what? The square root of the bottom. What is the square root of 1? It's 1. Now, over here, we got a nice whole number, didn't we? Do you get a nice whole number for 15? No, you don't, okay? Now, there's something, again, you might have learned this in Algebra 2. Math teachers or math people don't like square roots in the denominator. I don't know why. Really, I guess there's reasons. But they usually say, this is not simplified if the square root is in the denominator. So there's a trick, a little thing that we do in order to get rid of the square root in the denominator. I know you're dying to figure out what that is, but I'm not going to tell you right now, okay? We'll wait till we get to that, all right? There will be a time where we get to that. All right, let's continue with this. Let's do C. Now, this looks hard at first, but if you think about, we've already talked about this. if you look at this, this should be pretty easy now. Say it. 4? No, I'm sorry. It's not a multiplication sign, okay? This is a decimal, sorry. If it was multiplication, yeah, I have it a little high. Should be a little bit lower. It's 1.4, I'm sorry. So if it's 1.4, then what is it? It's just 1.4, isn't it? Why? Did I have to do any math? Yeah, the square root and the square cancel each other out, okay? So I didn't really have to figure out anything inside of there, did I? All right, it's just 1.4. And we talked about that before. All right, one more example, example 12, and it's a 3-parter as well. Let's go to this color. Yeah. Yeah, they fool you when they say example number. Okay, it's example 12. Oh, almost forgot. Let's do this. Remember I said when you take the square root, you always get a positive number. You won't get a negative. This is what allows you to say that you always get a positive number. So in this case, we're always going to use the positive version of it. There are times when you will use a negative version, but on this one, so that, what did we say this was? What happens to the square root and the square here? They cancel each other out, don't they? Okay, so you're just left with A. But we're going to say that all our answers are always going to be positive. You with me on that? So we've talked about this like the first day, second day, I can't remember. How do you make a number to make sure it's always positive? What do you put it inside of? Absolute value, that's right. So by putting the absolute value there, what does that mean? That ensures that your answer is always going to be what? A positive number. Make sense? Okay, so that's kind of like the definition that they write in there. So let's do a couple examples with that. Again, this is really not a whole lot different than what we did, but we're just ensuring that this thing's going to be positive by putting it in the absolute value. So what if you had this? 2 times 3. Now it is times this time. This is not 2.3. It's 2 times 3, and then you squared it inside the square root. Okay? So let's just use the 2 and the 3 right now. Well, we can use the 6. It doesn't matter. Let's use the 6. But do we just say 6 according to this? Right. Just let's make sure we know it's positive. It's always going to be that. Okay? Which will be 6. I'm not going to be that picky. This stuff right here we're going to do, it's almost not even worth doing, kind of. It's just being real technical about it, just to make sure that we always get a positive answer. Okay? Let's do this. Remember I said I can't have a negative inside a square root? Well, this is times again. It's negative 2 times 3. Then you got that squared. What's this going to be? Yeah, I tell you what, instead of writing just 6, let's write negative 2 times 3, but it's going to be inside an absolute value. And what is that going to be? That's still going to be a positive 6, isn't it? The absolute value just ensures us that we're going to have a positive answer. That's all that's doing. Okay, it's really not that big of a deal. Let's do one more. It's pretty basic since we just talked about this right here. It's basically the same thing as that. Stick an x in here instead of an a. It's really not that much different. It's just the absolute value of x. That's it, okay? So part 12 is not that big of a deal. All right, now you should be able, in the remaining time, when's this over? 25. So you got 17 minutes left. So you should be able to finish up numbers 39 to 83. You should have done everything except for maybe, what, 3 or 4 problems, something like that? Is that about right? I don't know. Where does it start? Somebody have their book open? I don't have the book open. Where do the square root stuff? Where's the square root stuff start? Probably 73. So you should have everything done up to 73. All right, so that's only what, 5 problems to do? Something like that? Okay, so let's do 73 to 83. Continue that on that section. And then here's your official homework for tonight. Okay, I'm going to put this in red. Yep, you got it on your paper, right. But I'll do this just for the YouTube people if people aren't here. So this is section 1.5. Did I put an A or a B on that thing? I did put B. You can't see that? How's that? Is that better? Okay. So it's so this is your homework for tonight, okay? This is your homework tonight. So it's part B. Now that up to 83, I want that by the end of class, okay? Because you got 15 minutes. You should be able to do those by the end of class. So it's on your paper, but again, this is basically for YouTube. 27, 28, and 85 to 107. Is that what I wrote on there? Odds. And remember, these are odds as well, okay? So 73 to 83, you're only doing 73, 75, 77, 70. Okay. Everybody good? Do you have your pass? Do you have your pass? Maddie, do you have your agenda book? Your agenda book. It should be with you at all times. It should be like your phone. You should always have it with you. Yes. Write out on a sheet of paper or something. Don't use somebody else's book. All right. There shouldn't be so much talking. You got 15 minutes to get those 5 problems or so done right here. So get the, and this is homework tonight. This is tonight's homework.